Knots Company welcomes you back to Focus on Automation, where we explore and celebrate advances that empower manufacturing. Welcome back to Focus on Automation. I'm your host, Todd Youngblood, and today we're going to take a deep dive into Lean Robotics. And to provide some insight to all of that, I have a guest that's joined me this morning. Please welcome Mr. Michel Beauchemin. He's Sales Channel Manager with Robotiq. Michel, thanks for joining us this morning.
Hey, you're welcome. Glad to be with you.
Just to get us kicked off here, Michel, tell us a little bit about yourself.
Well, like you were saying, I'm a channel sales manager for Robotiq. I've been working there since 3 years now in automation. Robotiq is a French-Canadian company based at Quebec City, which is 2 hours up north of Montreal. We're in business since 2008, where we, it was three PhD students that created the company because they didn't want to move to, let's say, the Michigan area, which at that time, back in 2008, was where the automation.
The center of robotics, right?
Yeah, exactly. So that's and then since then we worked on end effectors company. So we try to help deploy more Cobots.
Okay, talk a little bit more about Robotiq. You talked about 2008, and it sounds like a bunch of college buddies got together and put it together. Talk a little bit more about Robotiq and what you're all about.
Yeah, well, actually, Robotiq, when I joined 3 years ago, we were 35 employees. It was mostly, a startup at that time, but now we're 140 employees now. We're developing a lot of products. Now we call it families of products, and we mainly focus, we have grippers, family, vacuum company, sanding application, and also vision systems. But we mainly focus now on collaborative robot because it's a good fit for our product, but also because we're focusing on the ease of use and plug and play. So that's all about Robotiq right now. It's try to facilitate the deployment of those robots.
Well, it's interesting. I've been around the manufacturing world for quite a few. I'm not going to admit how old I am, but I mean, robots have been around for a heck of a long time. But you talk about growing from 35 to 140 employees in 3 years. That's really impressive. But it seems to me that just the growth in robots, period, is experiencing the same kind of explosive growth. Why is that?
Well, I guess it's there's 4 reasons why people look for automation, and that's right for every type of automation. So it's either lower production costs or increased production, or also improve quality. But what we see, and especially in Canada, but also in the U.S. as well, we're suffering from the same issues, the workforce issue. As you know,
right.
There's by 2020 there's going to be 2 million of manufacturing jobs that will be going unfilled. So that's why there's I would say quite a good interest into deploying automation right now.
Yeah, that always blows my mind when I see that statistic of 2 million unfilled jobs. It just, I can't help it. It makes me scratch my head. But you're right. Backfilling in that manpower requirement is certainly a big piece of it. There's also another term floating around that I think plays into that as well, and that's the word cobot. And I know you guys are into that big time. So give me a definition and why that's different from a robot, or how that's different.
Well, if we come back, like you were saying, that industrial automation robot, 6-7 axis robot are existing since a long time. They were what we call industrial robot, which is they were all, I guess it's a question of payload. They were able to lift very, very heavy parts moving around at tremendous speed and stuff like that. Those are industrial robots. They need to be guarded. They need to be, no human needs can work close to them because of the speed that they're doing. So in 2008, or approximately in the same hour, I would say era as Robotiq was created, there was also multiple company that created what we call collaborative robots. So that means that a human being could work close by those robots and without being actually injured or something like that, because there's their sensor in the robot that if it feels somebody against or whatever against it, it will stop, and it's not going at the same speed as well. And the main focus for those, and cobot is a slang word for that, so for those collaborative robot, what people are doing with those type of robot, it's not the same, industrial robot would still and will always exist. We're trying to automate manual tasks. So that's why working along human, doing the same type of manual task that a human being could be doing on a manufacturing floor.
Go into a little bit more detail on that, and then share, if you can, an example or two or three of what you mean by that, working alongside the human and manual
Well,
tasks.
yeah, the main application that we see, if we're talking about application, and then we're going to talk about the tasks that are related, I would say one easy application to start with is what we call machine tending, so tending a machine or doing pick and place. But let's say if we focus on the machine tending application, because I've got a few examples, where there's a CNC programmer that program, let's say, the milling machine or the lathe machine.
Yep.
And after that, somebody needs to load the machine, open the door, remove the raw material, put the machine part and load it with the raw material. So I guess this is like a non-added value task for a human being. Well, we're able to think, so we should be doing some more added value tasks like programming the CNC, try to I guess to figure out if there's some issues in the manufacturings and tolerances and more complex tasks like that. So a cobot would be able to just pick up the raw material, open the door, load and remove the machine part, and load the raw material and restart the machine. So while it's doing that, somebody else could be doing some more added value task.
Now that's interesting, because as you talked about that particular example, it strikes me as very simple. And a lot of the conversations I have regarding robots, and specifically is cobots, is the complexity of it all. Compare and contrast that a little bit. What you talked about seemed like a very simple application, and yet I have this feeling in my head that these things are really complicated.
We should say it's simpler, okay? Because it's still an automation project. But the issue is that there's no one fit all, in terms of a robotic solution. The challenge as well is not the robot, it's the whole robotic cell. So everything that's around it. If you think about that, the robot is just a moving arm. There's no brain behind it, So if you think the industrial robot, the controller has a language, the Robotiq pendant has a language. So to be able to just move the robot around, you need to be well equipped in terms of robotic knowledge to be able to manage all the communication, and also to figure out on top of the robot you would have an end effector, so you would have to discuss the language with the end effector. So that's a level of complexity. That's why in industrial robot, since the beginning, it's what we call system integrators that are really skilled doing it and putting things into place. If you think about the cobot, we are I guess some of the cobot brands on the market, they're focusing on the ease of use. So you have one teach pendant languages, and it's on the screen. It's really, I guess, intuitive in terms of the interface versus scripting,
Right.
like it was in industrial robot. So, but the challenge is not the robot itself, it's everything that surrounds it. So if you think about the machine tending application I was talking about, you would have to communicate, put the robot side by side to the machine, have to make sure that the end effectors that would pick up the parts in the machine are talking to the robot. The CNC machines is talking to the robot as well. You need to bring some pieces. So the complexity resides not in the robot itself, but how to put all the pieces together quickly and with efficiency.
I got it. So thinking about that robotic cell, as you called it, that helped me kind of get my brain around it. It is not just the robot; it's the entire manufacturing process, or at least a significant part of that process. I'm curious. Talk a little bit about the impact on the people. It seems like there are some folks that are going to be out of a job. That's a little bit of the fear factor you hear about it. It also strikes me that the skill sets required are different and perhaps dramatically different. So just talk through some of the issues surrounding the people issues surrounding implementing a robotic cell as you've described it.
I guess what one point I want to pick up is the fear of the robot. I guess that's why I think that there's two type of fears. One that comes from the complexity, like you were saying. The other one is the job loss. So a great example would be, a digging machine. So when we see a digging machine, do we see 20 people with shovel that could shovel, or we see a digging machine? So I think it's more like the adoption of the new technology. Regarding the complexity, I'll explain a little bit afterward how how we go to market and focus on the ease of use and what exactly does that mean. Regarding the job loss, I guess it's the robot itself are not thinking. We need to program them, so we need a human being that will be able to think and to program those jobs. So what we see, it's not a job loss, it's a job, I would say, transition to more added value tasks because you still need to program those robots.
Yeah, that makes sense. Yeah, nobody's walking behind a horse pushing a plow anymore to in the agriculture industry. And it sounds like it's a similar sort of thing. Sticking on the people thing, I'm picturing myself working on a factory floor next to this cobot that's moving around, and they in quotes tell me that if I get too close to it, it's not going to hurt me. Is there any fear in that, just physically? Well, how do folks react to all of a sudden, instead of working next to, alongside of another human being, working alongside of a robot? How do folks react to that?
Well, I guess it's just a new way of working. So you're working closer to a robot. Of course, they don't go to the same speed. They have sensor. It's, of course, you need to be, I guess, be conscient of the risk as well, because, that's right. If we say a cobot, it could work along with the human. But I think we need to think about the application it's doing, because if it's carrying a knife around, even if it's, collaborative robot, at some point it's not going to be a collaborative application. So I guess the fact is to have a collaborative application. There's a lot of devices to that sometimes could slow down the speed of the robot if a human being is working side by side. There could be synergy between the workers and the robot as well, where the robot is doing a task and then is waiting, just let's say the robot, the human or the operators to just tap it, so it recognizes that it needs to go to the other action because it was waiting like an approval from the workers. So what we've seen as well is that there's a lot of workers on the floor that named those robots as well, just like
That's interesting.
yeah, like another colleague.
You know what? I know I would do that if I was in that position. Let me shift gears a little on you, Michelle, and talk about the money side of it. Earlier, you mentioned that folks deploy robot cobot technology to decrease production cost, or to increase quantity, increase quality. Talk a little bit about the money side of it. If I'm going to make a significant investment in robot, what kind of payback can I expect?
It's a application market, so it's really depending on what exactly is the application. But what we've seen, especially in machine tending, you could have one robot that operates more than just one machine. I've seen some machine shop, for example, that are facing two CNC machine face to face. So at some point, you need to divide the cost of the robot or the deployment of the robots in two machine, and they work more than 8 hours. They don't complain as well, as long as they have significant amount of parts. So we see, based on those machine tending, application, which is, the reason I'm talking about machine tending a lot is that, it's one of the easiest tasks we've seen to start with in terms of deployment. And we see something like, 6 to 9 months of ROI. But of course, that's easy to say. It's really depending on the application, and exactly. So there's, we've seen customers that are deploying in 5 days, and some others that are, because of the application, it's and the way they prepare before, that they're going to be deploying in 4 to 6 weeks, for example. So it's really depending on the methodology and how you think before deploying, because that has a direct impact on the return on investment as well.
I'd like to poke at that a little bit more. Let's just say for the moment I'm a plant manager, and you and I have decided that you and I are going to work together on deploying some robot cobot technology in my plant. Just talk through, how do we approach that? How do you get your arms around what really sounds like a pretty significant project. What are the steps of walking through of deciding which application and which cobot and what personnel and what training, et cetera, et cetera? How do I work through all that?
Well, first, I would say that the first thing I would suggest is to, get a, get a hand on a Lean Robotic book methodology. It's a book that our CEO just wrote, and I would say it's a learn from others' mistake and how to be efficient in the deployment of those cells. So, by reading that, I guess what the Lean Robotic methodology told us is that the deployment is separated in three big phases. The first one would be the design phase, the second one would be the integrate phase, and the last one would be the operate phase. So if I describe a little bit more, like bird eyes view, what exactly are those phases? Is that the design phase is where you identify the application, you identify the people that is going to be working at deploying those. It's where exactly you do your homework before deploying, because a lot of people are jumping directly buying the equipment and jumping to the integration, which they find out some stuff while they're programming and deployment, and that has a cost delay in the deployment, which has an impact on the return of investment. So I would say the first step would be focus on the design step, identify the application. Robotiq has a service and coaches of integration, so we could guide you and help you. We also have a huge partner network worldwide, and those are our local, I would say, expert, like the Knox company. They could go into the shop floor with you. They could walk the shop floor, identify some, I would say, application to start with, which are easiest at the beginning to identify, because that's easy to say, focus on the easiest application. But since it's the first time you're going to be deploying a robot, that might be not really the application you would be focusing on. So those guys are expert, and we could help you, as you deploy in the design phase to shrink the deployment and make sure the deployment is done faster, and so that you're saving time as well.
Talk a little bit more about that integration part. It's obvious to me anyway that I've got to integrate the operation and the process that the cobot is going to do with the people, but I've also got to interface it with some of maybe many different IT kind of systems. How big an issue is that?
Deploying a cobot requires three things, and people tend to forget that those three things are important and focus on, the robot itself. And remember, the challenge is not the robot itself. So, to deploy a cobot successfully, you need to have robotic skills. You need to be able to manage a project deployment. It's like project management skills, but focusing on robot. It's not the same type of as in any mechanical project. And those are, what is really touching the robot side as well. But what people think and forget is that the key to the success of deployment is really the manufacturing process. And that's why, the end user or you, if we take the example that it's your manufacturing, it's what you are expert at. So I guess knowing how you're going to be, deploying and manufacturing at the end, that's the key to the process. Deploying and robot skills, I guess, it's a turning wheel. So the first, if you focus on the easy application first, you're going to gain in skills by programming it. You're going to be making, if we focus on the easiest one, especially at the beginning, you're going to be making, better return on investment from it. And then the success is really the first cell that you deploy, because it's a turning wheel. So you're gaining experience to it. And then that's going to be, more easier to deploy to a second robot that you're going to be deploying, but also, let's say, another application as well. It requires just understanding on how to be able to program those robots, and since those robots are focusing on the ease of use as well as the end effectors that gravitate, so that we're lowering the complexity using plug and play products as well.
Got it. Now you talked about the design and the integration both a little bit, and you mentioned the third phase of the implementation being operation. What kind of issues do I need to be aware of in the ongoing operation of one of these systems?
If you think about the design being where you identify the application, build a cell in terms of what are going to be the manual tasks and what exactly we want to automate and stuff like that. And when this is done, we fall in the integrate where we're putting all the pieces together on the shop floor. We're training, we're programming the robot, and then we're ready to deploy to the production line. That's when we fall into the operate phase where the robot is producing value. I guess in the operate phase, Cobot are bringing a lot of, I would say, continuous improvement where, we keep it, since the beginning, we say identify the basic application. What I see a lot in is when people understand what a cobot is capable of, they think of the cobot to be like a magic stick to solve every issue in the plant. So what we say is that, well, keep it simple at the beginning, but also in all those phases while you deploy. So because of the cobot bringing continuous improvement, we need to keep it simple as well when we deploy and producing simple tasks and creating value, then creating return on investment, and then going back to to the design phase of a second robot, for example. So in the operate phase is where you actually really measure the return on investment.
Got it. Got it. Makes all the sense in the world. Michel, let me ask you to put or look into your crystal ball a little bit. Look out the next 3 to 5 years, and what kind of developments and trends do you see coming at us in that time frame?
Based on the workers issues and stuff like that, and what I see is that the market right now has been growing at a pace of 56% per year, plus or minus, depending on the years, but an average of 56% because
that's staggering.
Well,
Wow.
it's going fast, So I guess we're in the phase where the first deployment at the beginning, it was let's say the early adopters, which were the lab testing, big manufacturing
Right.
companies that were testing the robot itself. And now they start to deploy in their production line. And that's why, the first cell was more on the simplest application where it was, loading and unloading the machine. Now it goes, based on the application, it goes to other type of tasks as well, which require more dexterity, more fine-tuning, or more sensitivity to the robot, like assembly of components in a production line, which are, which the human has always been really a great asset because of the sense of touch, the sense of the vision and stuff like that. And also to more complex application, which would be polishing, sanding, deburring, and stuff like that. So the trend is evolving a little bit, but as we grow, it's going to be the first cell. We're going to be duplicating those cells in the plant as well.
It's going to be fun to watch. I can't wait.
Definitely.
Yeah. I've got one more question for you, Michel. What makes Robotiq different? There's a lot of cobot manufacturing outfits out there. What makes you stand out?
Well, I guess we have always been focusing on the ease of use. Okay, that's a wide terms of the plug and play aspect, but we tend to mojo, if I can say it like that, at Robotiq is to start production faster. So like I was saying in the deployment phase, whatever the design, integrate, and operate, when people are deploying, there's a lot of non-added value tasks, which is a lot of delays and stuff like that, and those delays cost the time to start production earlier. So at Robotiq, what we're focusing on is, of course, we're creating plug and play products to like end effectors, like I was saying, to make sure that we're capturing and then we're putting down complexity to a level where everybody would be able to do it. Those are the tools that we're providing. In terms of service as well, with our partner network, we're really facilitating the deployment. So every time that we're developing a new product, but that we're talking to end user, our goal is to really make sure that person deploy faster. So what exactly are all the pieces that takes delay in the deployment? Then it's what we're focusing on to bring the value as well. So that's why we Orsi wrote the book Lean Robotic methodology. Methodology is just a way to deploy. There's no it's what we want to make sure that people that think about the automation do it with success, and it's learn from others' mistakes. So we saw a great asset of doing that.
Okay. I mean, what an exciting story. And I am going to remember that 56% growth rate, plus or minus. That's one fact that's going to stick in my head. Anybody that's in a management position in a manufacturing facility almost has to. It's a requirement, I think, to be looking pretty darn closely into this technology. Before I let you go, Michel, just how do we get a hold of you, or how do we get a hold of one of your distributors, and also where can we get a copy of the Lean Robotics book?
Well, first, there's a leanrobotic.org, which is you could find a free PDF copy of the Lean Robotic book. If you're more like a hard copy readers, the book is available on Amazon. It's easy to buy at low cost. Otherwise, if you just have to contact us wherever you're located, or go on robotiq.com. You're going to see also there's a lot of software to directly on the site to help you. There's a lot of ebook to what to think about. What you remember, the Lean Robotic was a methodology to deploy, but if you've got other questions before deploying in the process, you want to see how other people did it. So just on the robotic site, you're going to see a lot of those. And as well, we're going to put you in contact with one of our local partners if you need to actually kickstart the whole thing and want to see the robots and the solution in front of you. And then after that, to have one of our local partners to just walk the plant with you and identify some application. So I guess that would be the best way to contact us.
Excellent. Thanks. Michel Beauchemin, Sales Channel Manager with Robotiq. Thanks for taking the time to share your insights today, Michel. I appreciate it.
My pleasure.
That wraps today's episode. On behalf of my guest, Michel Beauchemin from Robotiq, and our sponsor, the Knots Company, I'm Todd Youngblood. Talk to you again soon.